Okay, let's go ahead and get started. It's 30 seconds past 9:30. Welcome to the third session of this morning. This session, as you can see on the screen, is combining technology, processes, and data to maximize the efficiency and data value. Nathan Humphrey is our presenter. Please check in your CVET app if you're keeping track of your attendance in the sessions. And with that, I'll turn it over to Nathan.
Thanks a lot. So as you mentioned, my name is Nathan Humphrey. I'm with Horrocks Engineers. I've been with Horrocks for just over 4 years now, and this is my first IHEEP conference, and it's been a blast here, just hearing the different topics and chatting with all of you guys about some of the cool, different, new technologies and processes that are popping up. There's a lot going on, and it's a really exciting time. And so with that being said, my presentation today is going to go through some of the ways that we found success in really combining a lot of those new technologies and processes and data that you gather on a project together to be able to maximize the efficiency and the data value that you're getting. So the opportunity for improvement, as you guys know, since you're here at this conference, transportation technologies are currently exploding. They're ever expanding, there's always new stuff coming up, and a lot of times those features operate as though they're independent of each other, and they can also be really intimidating. I know I've sat through some presentations here, and it sounds really exciting, but it's also kind of intimidating. I don't know how to get started, I don't know how to jump into some of these things, and so due to that, they seem to require more often unavailable resources to really get into and start using some of these tools. And so due to those constraints, a lot of the efficiencies that are capable from these new technologies end up being underutilized. And not even just underutilized in themselves, but underutilized in the way that they're combined throughout the different pieces of a project. So here, like in the bottom right, we have an example of some cool design work that was done on a project. In the top left, we have a snippet of our field inspection app, and then the top right is obviously the actual work itself occurring. And so those pieces all play together, but sometimes the information that needs to be shared is not shared in an efficient manner, and a lot of that benefit is left on the table. So our solution that we've been able to implement is to combine all of these different processes into one central database. And the system that we have set up, we call it CIMS, or Construction Information Management System. But the main idea is just taking all of these different pieces of software and tools and combining them into one central location that can then clean and interrelate the data. So we use off-the-shelf software like Google Suite, Microsoft Suite, Adobe, Bluebeam, Power BI. We also use owner and contractor and third-party software on different projects. SharePoint site, ArcGIS, those are also off-the-shelf software, but we pretty heavily utilize them, so they get their own icons on this. SQL databases, and then we have some custom tools and a custom field app that we've set up. And all of those play into our central system and spit out enhanced interrelated data. And so similar with all the different tools, we have different pieces of projects, right? You have your design teams, your field, lab, office, PM, and they all have their own tools and processes that they use and that are specific to them, but it's all dealing with information that is relevant to the project. And that information needs to be shared with all these other groups in a way that allows everyone to maximize the benefit that they're getting from the other groups that are providing the initial information. And so I'll go through and I'll talk about some of the tools that we've used in these different groups, along with their pieces of software and processes, and how we've had success turning that initial unrefined data into cleaned, interrelated data for the project. And I'll talk about some of the successes that we've had on 4 different projects. So we have the US 89 Progressive Design Build and the 5600 South Progressive Design Build. Those are 2 projects just north of Salt Lake that are a little bit bigger scope of projects, and we've used the full implementation of all of our systems on those 2 projects. Then we have the West Davis corridor. That's also just a little bit north of Salt Lake. And on that project, we had a different organization doing the QA work. And so our piece was to pull information from all of their databases and their tools and merge it with information from the project management side and find a way to be able to get that information to play nicely together so that we could run some validation on it and make sure that everything was syncing up and clean together. And then we also have the Laredo Border Wall project. This is a project in Texas that had a large amount of work, but a smaller scope than these other 3 projects. And so on that one, we were able to deploy kind of a scaled-down version of our SIM system to better fit what the project needs were. So starting off on the design side of a project, we have some tools set up that work to manage and really shepherd items through the design process. And the way that those work is the designer would go in, they would load up their design submittal item with any details that they have, links to backup documents. And then based on whatever group they assign it, so whether that's geotech, roadway, whichever disciplines on the project need to be involved, an email would automatically be sent out to any of the people assigned to those groups. And that email would let them know there's a new design submittal in, it's ready for your review. It would give them details, links to that backup document, as well as links to like Bluebeam if the review is being handled there, or whatever system is handling that review process. And then they could go in, they would drop in any of their comments, and based on whatever the next step is, another automated email would be sent out. So if that needed to go back to the designers for some rework, the designers would be notified that it was ready for them, or if it was being moved on to project management for approval, they would get an email letting them know, and they could see any comments that had been on there so that they could track that whole process and then close it out with confidence. And then once that process is complete, those items stay in that database and become available to anyone throughout the remainder of the project who would need access to it. So that way it's always easy to find any of the pieces that you're looking for throughout the rest of the project. And we have similar tools set up. I just talked about design change, but we also do that for technical directions, NCRs, CDRs, RFIs, any of those acronyms that represent processes that need a lot of collaboration coming together from multiple different people. It'll shepherd those along, make sure that the ball's not getting dropped along any of those processes. And then moving on to the field side of things, so once the design is complete, the design work gets loaded up into CAD and ArcGIS, and then linked up with a custom tool interface for our field users. And they can go in and pull up on our field app that we have. It'll show exactly on the map where they are and where those plan sets are located. So they can pull up those plans when they're out in the field, see exactly where things should be getting built, and then they can draw their inspection reports directly onto that ArcGIS map. And that becomes really useful, one, in helping our inspectors know where things should be located, but two, it also provides a lot of information on the review end so that you can know that things are being covered. So if we look down at this bottom image, it's a little bit hard to see what's going on there, but all these lime green areas are areas that have been covered by tests. And so if I was the reviewer, I could look at this image, and this is from our US 89 project, and I could see there's pretty good coverage along all of that pavement area, except for this little section over here on the right side. And that would cue me in that something is going on there. Either testing was missed in that area, or more likely, we have tests on both sides. That area was probably tested. The inspector either just didn't get it logged correctly, or something else was going on there. But it really cues me in like, hey, this area needs a little bit extra attention. Take a look at that, see what's going on. And then that way, you can have confidence in your coverage. If I was reviewing this item for payment and I saw it was green all over, I would still want a spot check to make sure that I was comfortable with what was going on and things were being logged correctly. But it makes it pretty easy to glance and see I have a fairly strong amount of confidence that this whole area is covered. And then along with those reports that they're logging in, since they're all geolocated, that can be exported, and it really becomes beneficial with asset management later on. So let's say a few years down the road, we're having an issue with a section of road or a structure that went in as part of this project. You could pull up that area and see exactly what had been logged throughout the whole construction process. You can see photos, inspection reports, control points, and you can really get the full idea of what occurred as that item is being constructed. So it becomes really useful in the short term on the project and also for long-term use. And then another awesome piece that we've started incorporating from the field are contractor and owner utilized tools. So this one is an example of e-ticketing. E-ticketing is great because anytime you can eliminate the need for paper to be handed back and forth between different people, saves so much headache. I can't tell you how much time I spent digging through boxes of physical paper concrete tickets looking for one specific one that wasn't included for whatever reason. And e-ticketing eliminates all that, and it really just speeds up the process. Some of the tools and metrics that we're able to pull out from systems like these, this top left is a task tracker that we've put into place on the 5600 South project. And it pulls information in from all of the logs that I had talked about at first and breaks it down by person responsible. So again, it's a little bit hard to see what's going on here, but in this top left one, it's broken down by role. And so that second line there is CQCM, that's the quality manager. So if I was a quality manager, I could look at this table and I could see I have 2 technical directions waiting on my attention. The rest of the line is blank, so I know I don't have anything else. If I click on that 2, it'll take me to a filtered view of the technical direction table, where I can see exactly those 2 items that are open waiting on my review or attention, along with their details and links to any of the backup items. So I can pretty easily go in and see exactly what's on my plate and get those things taken care of. And then it also has the effect of helping to identify bottlenecks in the processes. So if any of those numbers in that overall table start to really shoot up, you can know that something is not being done the way that it should be or in a timely manner, and you can follow up with that person. Maybe they didn't know that all those items were waiting on their review, maybe they weren't familiar with the log or the tool, or maybe there's something else going on. But you can see those things starting to pile up before they really sit for too long and become bigger issues. Some of the metrics that we're able to pull out of the field side of things. This top right image is an overall view of reports and their status over time on the project. So we have a little bit zoomed in view over here on the left. And this is just a line chart that shows the status of inspections on the project. So those top 3 solid bars are just total inspections and the ones that have been reviewed and approved. The dotted lines on the bottom are ones that are waiting to be submitted or have issues that are open. So the specifics are kind of hard to see, but it's not super important. The basic idea is you're able to identify, again, any bottlenecks in the process. If you start to see the errors or the issues that need to be taken care of really shooting up, you can jump on that before it becomes a big problem and resolve those issues. This bottom left is a chart that monitors the workload across the inspectors on the project, and it makes it really useful to see, one, if any of your guys are just really being overworked. If you have a huge bar, you can check on that person, make sure they're not getting burnt out, and get them some extra help if they need. And 2, the flip side of that, on this one, density tests are in white, and you can probably see there's no white on any of these bars. So if I was looking at this from a project management standpoint, and I knew that there had been density tests in the last couple weeks, and there's no density test showing up on here, again, that's a flag in my mind that I need to do some more investigation. Either that earthwork didn't occur, or those tests aren't being entered for some reason. Whatever the case, you can really jump on that quickly and get those things resolved so that the problems aren't getting buried. This image on the right shows average work times for control points. And we have those set up for all the different work types as well, whether that's density tests, control points, inspections. And what it is showing is how long it's taking the field inspectors to enter in these reports after the work occurs, and then how long it's taking them to get processed and approved. And again, that really just helps you identify any potential issues early on. If you start to see that it's taking anyone a long time to get their reports in, you can chat with them, see if they're having a hard time for whatever reason, and get those resolved. The basic idea is you don't want reports taking a long time to get in because the work is always progressing, things get buried, it becomes a much bigger deal if there are issues that you need to correct. This tool that we're showing here is another useful piece that comes from having all of those reports and tests geolocated. And what it is showing is in 3D, all these red dots are density tests. On this project, we went through a span of time where it was discovered that some of the inspectors had been using the wrong proctor on some of their tests. And so we were able to plot all those since they had the geolocation and then the elevation based on which lift it was assigned to. And you can see, it's kind of cool, they follow along exactly the lines of the drainage plan, which is what you'd expect since that's where they're doing most of this density testing. The red dots are ones that were determined that they would be failures if the correct proctor had been used, and the gray ones are all other density tests. And then by clicking on any of those dots, it'll pull up a summary of all the details associated with those tests. And so we were able to give this to the project materials engineer, and he went through and investigated based on the location and the depth of all these failing tests, and was able to give us a report on the potential impacts that came from those failures in those areas. On to the lab side of things. All of that field information that gets entered in that's applicable to the lab crews will automatically be pulled over into the tools that they use, and vice versa is true also. So when the lab crews go in, they run a gradation, they get a proctor, any of that information that the field staff will need gets pushed back to the field side so that they have it in real time. So we have tools set up for all the lab entry that they would need, and then this bottom image is our MS&TR minimum sampling and testing requirements tracker, and it makes it really easy. You can identify in red based on the amount of tests that have been plugged in and the area that's been covered and the material that's been used. We should expect this many tests. If you're good, you're in the green. If you're missing any, you're in the red. Again, just a quick and easy glance over to see if there are any things that you should do some deeper investigation into. This image is part of our lab tools that has been really beneficial. We started, I think, on the West Davis project, but we've been using it on all 4 of those that I talked about at the beginning. And it basically guides the lab staff through assembling the concrete packets. So it will pull in all of the field testing information on any concrete test, and then based on the project requirements, it'll give them a checklist of what needs to go into those concrete packets. And they can drag and drop directly into this tool, and then you'll be able to spit out a PDF of those concrete packets. And by expanding any of those concrete lots, it'll pop open a more detailed view, and this is where the lab crews can go in and enter in any of their break data or other lab data that they have. One request that we got on the West Davis project was that they really wanted daily review emails to be able to keep up with any of the work that had potential issues. And so we were able to go in and program some automated emails that went out. These ones on the left are issues emails. So the field engineer who was responsible for the review of all of these reports that came in would get an email that broke down all of the current open issues across all of the different report types for the project. And then each inspector would get an email that was similar to this, but it would only show their particular reports that they were responsible for. And that made it really nice. You could see every single day what issues were open waiting on resolution. And so again, it just made it quick and easy to resolve those issues before the work progressed and things got buried or repeat issues popped up. And then this one on the right is a similar one that we had set up, but it was for PCCP coring windows. And basically it broke down all of the PCCP cores that were within the testing window. It would also call out any that were past due that hadn't been tested and any that were upcoming. So that way anyone on the project who was working with the PCCP cores knew what their current workload was and what was coming up, and if there were any that had been missed. Now the project manager review and the payment and final documentation side of things is where all of this really gets pulled together. And so throughout the process, whether it's the design side, the office side, field, or lab, all of the information that gets entered in gets tagged to one or multiple pay items on the project. And we have a pay item summary tool where you can punch in whichever pay item you're wanting to look at, and it'll automatically pull up all of the pieces of information across the whole project that have been associated with that pay item. So that becomes super useful when it is payment request time. So the contractor says, we're 100% done with this pay item, we're ready to pay it out. The project management can go in, they can pull up that pay item number, and they can see, okay, let's look at all of the certs and submittals that came in for it, make sure they're all approved. If there are density tests, concrete tests, they can look at a summary of those as well as detailed views. So if you're doing an audit and you want to spot check some of the tests that came in, you can pop those up right there in that view. It has links to all the backup submittals as well, so you can see any of those if you have questions during that review process. And it will also identify any current issues associated with that pay item. So if there are NCRs open, if there are punch lists open, those can be seen really easily on this view. And that goes a long ways towards confidence when you're paying. Obviously, you still want to spot check, but you can pretty easily identify if there's anything missing there and then pay with confidence when they're ready for 100% payment. And then it also makes it really easy on the final documentation side of things. You can export a package summary that includes all of that information with a nice cover sheet that summarizes what's in it. And that can be exported in any format that the project requires, whether that's PDF, SQL database, ArcGIS, basically anything that the project needs, it can be exported to fit that. Now, along with the payment review, it's fairly common that items that are requested for 100% payment are not ready for 100% payment for multiple reasons. Either the work's not done, or documentation's not there, or there's testing cleanup to be done. And so we set this up on the US 89 project, but again, we've used it on, I think, all 4 of the projects that I introduced as examples. This is an accounts receivable tracker, and it's an interactive report that houses any of those items that are held back on payment for whatever reason. And then it breaks down who the responsible party is, what type of item is missing before payment can be complete. And that makes it really easy to manage those items that are being held for payment. We ended up with a pretty big list for a span of time over the project. And so this made it nice. We could go through and start getting those items closed out and getting the contractor paid for work that they were ready to be paid for. And then another really useful piece of information that we were able to pull out of our systems is this bottom image. And this is a budget tracker that we used on the US 89 project as well. And what it is showing, the blue bars are basically the number of field staff justified month by month based on the construction costs. And the orange bar is the actual field staff that we ended up having. And so you can see for the first third of the project, the amount of staff that we had. I'll just talk loud. Hopefully you guys can hear me okay. The amount of staff that we had for the first third of the project was less than what was actually justified. And so we were getting comments from the field crews saying that they were being overworked, they needed more help to be able to adequately cover what was going on. And so the project management made a switch, and then you can see for that middle section of the project, it's flipped. We ended up having a lot more field staff than was actually justified, which was okay for a little bit, but then we got to a point, especially in some of these winter months here where the gap is really big, where we were really overstaffed. And so project management, we were able to project that out where we would have ended up, and they saw that we were gonna blow out the field budget if we kept up at that rate. And so we were able to scale that back a little bit, get it kind of more dialed in so that we could adequately cover the work while still remaining within the budget. So just to summarize, kind of the overall benefit that comes from using a combined system like this where you're pulling together all the information. On any project, there's always going to be a gap in the time that it takes to collect data, right? So you need the data, but it takes a while to collect it, and then it takes even more time to scrub it and clean it before it really becomes actionable. And so you're minimizing the amount of actionable data or information that you have. And then once the project hits substantial completion, that closeout process takes a long time. It can be really painful because you're going through, you're having to clean up reports, you're having to find all the documentation and get it organized and ready for that final documentation and project closeout. With a system like this where you're able to merge those things together throughout the whole process, you can really shrink down all of those gaps. So it still takes a little bit of time to collect data, but that process is sped up with these more advanced tools. And the time that it takes to scrub that data into actionable data almost becomes instantaneous. And so in real time, that data is becoming actionable. You're able to maximize the amount of actionable data that you have on a project, resolve the issues as they pop up before they get buried, before they become repeat issues. And then at the end of the project, the closeout time becomes so much easier because you've been closing it out and organizing things as you go. So I would just encourage all of you, find ways on your projects to link up the systems that you're currently using, and as you progress to newer pieces of technology, keep in mind how you can merge those better together throughout the different aspects of your project. With that, we can open it up for questions. I don't know how much time we have. We're probably pretty good. Yeah, good.
How are you georeferencing your test data? Are they inputting station, offset, and then depth below material, and then that's manual process, or how are you able to georeference where that test location is?
Yeah, so the first part of that is they'll go out there like with an iPad and it'll have the built-in GPS, and that is a good starting point. It gets accurate sometimes down to 3 feet on an ideal situation, but it's not always that accurate, right? And so we have the alignment built in, so based on where they're drawing their lots on the GPS or based on plan set, it'll automatically populate that stationing. But then they also have the option to override that if it's inaccurate for whatever reason and they know, like, hey, this is actually the stationing. They can type that in